Good afternoon, everybody. Welcome back to lecture number 19. We are at week 7. We're halfway in the semester. So today we will go over the 2 examples to finish the material. Do you want help session?
Yes.
So we will have a short meeting today. From what time do you want?
Evening.
No, ما ينفع في الليل.
4.
لا وش 4
4 is good. 4 until 5 is good.
وقت الفطور تكثر.
It will be recorded.
في PPR حق اليوم.
Yeah. It's online.
ما في خلال 9
Okay, do you want it tomorrow?
لا.
Tomorrow, so that you study today, you come up with questions tomorrow? Who wants today? Who wants today? I don't see it in their hands yet. Who wants tomorrow?
دكتور الهيلب سيشن بس أسئلة من عندنا ولا كيف؟
I will go over the what's important here. And the receive your questions.
ما تتسجل؟
It will be recorded, yeah.
Today.
So it's a short one, maybe 45 minutes, not long. We'll just go over the material real quick.
ما ينفع نخليها بعد التراويح أو مثلا ممكن نخليها
I don't want to work at night. I have life. Okay? Okay? Let's do it 4 p.m. Okay? 4 p.m. And it will be recorded and I will go over. I don't think I will be solved the practice problems. I don't think I'll solve it. We'll just go over the material, pinpoint what's important, okay? Just summary. So in the last example, we talked about the motor in example 4 has load torque that is constant. So the ratio between the torques under 2 different controls would be from column number 1. Column number 1, okay? Column number 1. So what are we changing? We're changing voltage. So we use this equation. Clear? So we expect to see something like that. Now in the example 7, it's very easy and it's very important because it might come in the test. In example 5, he's giving you the voltage, which is 480. He's giving you omega, which is 2 pi times 1200 over 60. He's giving you R2 prime, which is 0.5. And he's giving you the torque to be 120 Newton meter. What is missing? Slip. So you calculate the slip, it's 3.27%. Then you get the new speed. The new speed is 1200 times 1 minus the slip, which is 1160. Now, he is telling you we have reduced the voltage by 20%. So reduce 480 by 20%, multiply it by 0.8. So if you do 0.8 times 480, your new voltage is a 384. Your new voltage, okay, he didn't do it here. So 384 square, divide by 480 square. S new over S old, what do you want? You want S new. So it's 480 square divided by, so it will be V square over V new square times S. What is S? 0.327. So what's the new slip? It's 5.1%. So if you reduce the voltage, would the speed increase or decrease? Decrease, because the torque would decrease. So what's the new speed? It's 1139 compared to 160. So a 20% reduction in voltage resulted in 5% reduction in speed. Is this example easy?
Looks like it.
Can you solve it in the test tomorrow?
Sure.
If we change the numbers? Okay. So these are one of the questions. Now example 4, there is an objection of example 4, so we're asking what?
انا ما بس من بعيد بقول لك ان
No, you have to come, man. ما في شيء من بعيد. You have to come. So let's start together. me and Mr. Nawab, let's read the problem first.
No.
So we have 20 minutes.
احلها كامله بس
No, tell me where, no, you have to solve it with me, okay? You claim إنه في خطأ.
في خطا في القيمه بس يعني ممكن ما ادري تايبو.
طيب
ما هو بس تايبو حتى الكالكوليشن غريب شوي. يعني هنا اوريك انا اياها بس ان الار2 استعملها 0.4
طيب.
مع انه في الكويستشن 0.5 هنا استعملها 0.5 ف
That's the only mistake?
وتحت برضه ماني عارف متى نستعمل 0.4 ومتى 0.5 الوضع غريب شوي.
No, R1 is 0.5, R2 prime is
R2 is
0.5.
also 0.5.
Yeah, you're right.
Also, the other thing is the calculations for the gap. I was going to ask you when do we make a count for the losses? And
Okay.
when do we just use this?
So we will go
the
over
short
it.
cut?
Okay, خلاص. So yeah, there is a typo in the calculation, but conceptually it is correct. Conceptually there is no mistake. Let's go over the question. 3-phase, Y connected, 30 horsepower, this is the rated output. 480, 6 pole, 60 hertz, slip ring induction. Has N R1 to be that, R2 prime to be that, and rotational losses are 500, and core losses are 600. Assume that the change in the rotational loss is due to the change in speed in minor. So those losses, 500 and 600, are what? Are constant. The motor load is constant torque type. So what does that mean? It means if you compare any two operating points, the two torques ratio would equal to 1. Okay? Because it's a constant torque. At full load torque, calculate the speed of the motor. That's the first question. At full load torque, calculate the speed of the motor. This is EE360, I'm assuming. So how does he solve it? He solve it using he already knows the output power because it's rated. It's 30 horsepower, and he already knows the rotational losses, which is 600 plus 500. No, which is just only 500. Core losses are here. So he added the 500 to 746 times 30, which is 22.88 kilowatt. So what is this? This is the developed torque, or P converted. It is the power that is converted from the air gap to mechanical. Okay? So then he used the formula, the simplified formula, V square S over omega S R2 prime, to calculate, here he wants to calculate the slip. However, so this is the torque, it's times omega. So omega is function of the slip. Omega is function of the slip. So this is a function of slip. Torque is a function of slip. So we expect to solve an equation that is quadratic for the slip. Do you see why it's a quadratic? Because we're multiplying torque times the speed. So you already know PD, and here, let's fix it. This is 0.5. Okay? Now, 480 squared times S, what is the omega? Omega is 2 pi over 60 times n. You agree with me? Mm-hmm. And what is omega s? 2 pi over 60 times ns. What is the, if you divide both of them, you cancel the 2 pi over 60. What is n over ns? It's just 1 minus s. You agree with me?
Yes.
So that's why we have this 1 minus s alone. It's math. Math is hard. Do you see why we have 1 minus s now? Now, if you solve this equation, what will happen? Let's try to solve it on the board. I'm not going to remove this from the exam, but let's hope it doesn't come. Let's hope. It may come. It might be the A plus. So let's solve this equation. So this is 0.5 times 228, 0.5 times 22880. it is 11440 would equal to 480 square S minus 480 S. How can I make it better? Can I make it 480 square S minus 480 S minus 11440? Can I solve equal to 0? Can I solve this?
Yes.
Yeah. Using calculator, you put the A to be 480 square, you put the B to be minus 480, you put the C to be minus 11440. So you should get 2 slips. We have an issue.
So maybe the solution used the 0.4.
Yes, the solution
Yeah,
uses
exactly.
0.4. Now we are using.
But even let's use the, I want to fix it. Let's fix it. Let's use the, I think I have an issue here. 0. I got 22% slip.
هو السكوير على الاس ولا على 480؟
Oh, you're right. 480 square. There's another.
لا في المفروض في اس سكوير بس.
في سكوير.
في 480 square double.
Oh, math is hard. Let's do it again. So it's gonna be 0.4 times 22880 would equal to 480 square S minus 480 square S. So fix it, it will be 480 square S square minus 480 square S
صح. زائد.
إلا يا أخي.
مظبوط.
plus 0.4. Is it 0.4 or 0.5?
0.5.
5 times 2288. خلاص, this should be fine.
2 slips.
480. Yeah, you should get 2 slips, I know.
It's
One,
not
one is
rejected.
rejected.
Yeah, 0.05 to 39.
So slip 1 is 0.94. This is rejected. Slip 2. Why it's rejected?
ما ادري والله.
Because it's too large. This is the only one that works. So that's the correct slip. It's 0.05, not 0.0. Not 0.0. So you can solve it على 0.4 or continue. What I can do is, وين بعدين استخدم 0.5 في losses?
استعملها في الار عادل استعمل 0.5.
Okay, that's okay.
كل شوي يجدد واحد.
Okay, so what's the new slip?
0.
0.0. Did we start the recording?
ما أشوف من عندي.
It's your responsibility. So 0.0524. So what's the new speed? What's synchronous speed? 120. The new speed that is calculated is 1137 RPM. So you may ignore this. Okay? Clear? We finished the first part. Now the second part, calculate the added resistance needed to reduce the speed by 20%. This is part 2. How did he solve it? He divided, go back to the table. Now the formula sheet, it will be approved as it is, okay? It will be approved as it is. When Ali? So it will be approved as it is, okay? I will print it. I will print it, it will be the last page in the exam. Okay? No need to print it. So what is our resistance? Constant torque. We should deal with this. So if you deal with that, you write down the equation, you solve for add. What is R add? 2.3. Now is it right or correct, the calculation? This one is correct? It uses 0.5? Okay, so this is correct. Question number 3. Calculate the motor efficiency without and with added resistance. So this is a very long question. So to get the efficiency, what did he do? Is he first started without RN, which is E360 style question. So he already knows the developed torque, so he wanted to get the current that goes I2 prime. He used this equation, PD, no, he used one of the older equations. The PD can be written 1 minus S, PG. PG is a 3 I2 square R2 prime over S. So that's why he used this equation. 3 I2 prime square R2 over S times 1 over S. So this is PG. So he calculated the current. He used 0.4. So let's use 0.5 and redo the calculation. So it is 22880 times 0. The slip here should be
0.0.
0.0524. 0.0524. 0.
ايش الدكتور؟
هلا.
في اللي فوق هو استعمل السلب اللي حق البوينت 4.
Yeah.
فحتى هذيك
Where he used the 0.5?
He used it in the equation.
لا هنا تحت. وين هنا تحت؟ Where did he use 0.5?
I'm not sure.
طيب خلاص, why don't we make this 0.04 وخلاص انتهى الموضوع.
لأنه يقعد سويتشنج.
لا, he never switched. I don't
في
think.
الار هذه الثانية لو تحلها بالبوينت 4 لا فوق هذه اللي هنا.
So he put here 0.
هنا بنحطها بوينت 5 بس السلب جابه بالبوينت 4.
Okay.
شوية والسولوشن صراحة كله نسي. كان بيني دم.
For remote.
I will try if I okay, here is the deal. If I upload the new solution, it will be required. If I don't upload the new solution, it will not be required. Okay? Good deal?
You mean your revision or separate part?
To me, the concept. No, I'll probably post a new revision with the new equations. But let's continue. Let's try to solve it here to get the numbers at least. Then we'll take photo. Then I'll try to retype it. So here you said he used the old S. So what is the solution if you want to use the new S? 0.0524 times. What is S new?
السنين ناخذها من ال
20% less.
20% reduction.
So if you reduce it by 20%, it means you increase the slip
Yes.
by 20%. So what's the ratio? S over S new, is it 20%? It's the same, it doesn't matter. It's the same ratio. Can you do the calculation? What is S?
0.0524.
If you reduce the speed by 20%, so 1137 times 0.8, what's the new slip? So N new is 909.6. What's the corresponding slip for that? The corresponding slip divided by, so it will be 1 minus S would equal 909.6 divided by 1200. And then 1 minus.
0.242.
So S new is 0.242. 0.242. 4. Yeah, it's 0.21. The ratio is not 20%. The ratio is 0.021. It's not linear. So this is 242. Solve it. What is the new R? 0.5 times 0.242 minus 0.0524 times 0.5. I think divided by 0.524. I think it's 1.8.
Yes, I think so.
Okay? It's 1.8 ohms. Okay? Let's continue. Then he used these calculations with these numbers. What's the new I2? Are you sure it's 1.8? I want someone to verify.
I verified it at home. I also got 1.8.
You got 1.8? Okay. Then what is I2, the new one? Do the calculation. 22880 times 0.524 divided by 3 times 0.5 times 1 minus 0.524 and then take the square root of 2. I got 6 amps. Did you get 6 amps? 22880 times 0.524 divided by 3 times
I got 30.
0.5 times. Okay?
30.
Yeah. So I got I2. I got 29.
29.
No, 0.04.
Yes.
Okay? Then did he put here 0.4? Well, we got a new current. So 3 times. What is R1? 0.5 plus 0.5. So it is 25301. Okay? So what is your input? Two 6 kilowatt. See, it doesn't matter. It doesn't matter. Doesn't matter. For efficiency, who cares? So what's the, I'm gonna say the efficiency is the same. What's the difference between 25.9 and 26? Okay? So that from here the solution is correct. Now we got the efficiency at the slip without R add. If you add R add, things will change because you'll get a new speed, you'll get a new slip, you'll get everything new, and you can resolve it, and you should get a reduction in efficiency of 70%. I'm not going to ask you to do the calculation of hours or cost. Is it clear?
Yes.
So up to slide 39.
No, let's do it. So it's clear until here, right? We did solve it
Yes.
with the new calculation, and it turned out the efficiency is the same.
قصدك هنا يعني الافشنسي
No, we still have time.
لا كان في ذا الاكزامبل يعني
Hmm?
كان في ذا الاكزامبل يعني نوقف هنا عند الافشنسي ولا ننزل تحت كمان
No, you have to do the efficiency with after adding the R. If we do the efficiency after adding the R, you have to get, now you added the R, you should have a new speed, a new slip, which he compared with the speed of 1150, which is wrong. So you need to compare to the speed 1137. So 0.8 times 1137, which is 909.6 RPM. We got the slip. What's the slip? We already have it here. 242, صح? 24, 2.42%. Now, you should compare the two power. Basically, you compare the two torques. The ratio between the torque is 1. So your new developed power is 18.3 from the old power. Then what should you have? You should have the new calculation of I2 new to be 25.73. I hope it's the same. And then you have to continue with it. We don't have time to do it. But the way he did it is he, instead of doing PD, he compared the ratio of PD from old to new. If you reduce it by 20%, your developed is 18.3 compared to your developed power of what was it? 22.8. Then the new current can be calculated to be 25 amps. You repeat the same calculation, and then you should get efficiency of 70%. Why? Because you have the copper losses are larger now, 6552, because now you have R added. So the efficiency is a 70%. So the only out of the 6552, 4.5 is due to the added resistance. And then you do the cost power calculation. He have it in 1 year. In 1 year he runs it for 5,200 hours. You multiply it by 0.05 times the total power, and then you get $1,000 per year, just for having an added resistance. You can resolve it now yourself. Okay? Clear? Any other question?
الحين عندي سؤال على example 1.
Example what?
اي example 1. وش الفرق بين الموتور speed والspeed of rotor field relative للمدري ايش؟
What is it? This one?
إي. وش الفرق بين الموتور speed وال
Part E?
اي والباقي الاي والاي ايش الفرق بينهم؟
Well, synchronous speed and motor speed. Synchronous speed is the
المعروفة.
the motor speed is the current one that you find from the
Understood.
speed of the rotor field relative to the rotor structure. What did he say?
I think
90.
with the slip.
Same as the slip. Okay. A rotor field. Look at the third part. It has the same speed as a stator rotating field. They rotate the same. It's the magnetic field that is coupled with the stator. It is a magnetic field.
يعني مو الروتر نفسه.
No. It's the magnetic field that bites the rotor. عشان كده هو نفسه حق الستيتر.
عشان كده صفر.
صفر. It's the magnetic flux يروح من الستيتر على الروتر. He's asking about the same flux الRMF حق الستيتر once it enters the rotor. هذا يسمى الروتر magnetic field. So when you do the simulation, you have stator, you have rotor. You remember these arrows?
Yes.
So he's asking about this portion of the field. That's why it is a stator rotating field. It rotates same as the stator. RMF. You got it now? The rotor does not produce RMF in the induction machine. Clear? So we're done with the material. Everything is included until here. Remind me to have the session at 4 p.m. We will go over the material, tell you what is important, what is not important. Try to attend, okay? Try to attend. But this example 5 is really, example 4 is not an easy example. I agree with you. It has so much work. Okay, can you solve example 5?
Of course.
Yes.
Do you want example 5 in the test?
Yes.
Okay, maybe, let's try. Maybe in example 5, I would maybe change stuff like, for example, I change the voltage to be increased by 40%, something like that. Okay? And then I will ask you another question, maybe. Maybe another question, how much is how much torque needs to be maintained in order to have a 5% reduction of voltage, a 20% reduction of voltage would have a 5%, 20% reduction in speed. Something like this is A+ question. Do you get it? How much torque needs to be? So I want you to get the torque that gives you the slip that you design.
So the slip is a fixed number you have.
No.
No, but you should give us the slip at least.
No, I shouldn't give you the slip.
How can we?
I should not give you the slip.
So we calculate the slip.
I give you the ratio between the two slips and I ask you to get the torque. يا أخي خلاص تبغى ما نلعب في الماء؟ إحنا we're here to learn. Okay, I'm not gonna make these tricks. Did you see the quiz today?
Yeah.
Was it conceptual?
Listen,
Okay. Any tricks fee? Non-conceptual?
Directly.
خلاص? So tomorrow is the test.